Ladies and gentlemen, we have received unprecedented visuals and signals that have never been witnessed before, arriving simultaneously at the same observation panel. Together, they lead us to a question that seemingly remains unanswered. What is Atlas? Precisely. In the past few weeks, three distinct elements have come together to create a troubling enigma. Firstly, recent images reveal a continuous structure accompanied by a colossal Secondly, there are reports of a forward jet exhibiting surprising Lastly, we have a series of temporal signals, which include gamma-ray burst reports. Furthermore, a set of measurements defies the conventional comet model. When we consider all these aspects collectively, the notion that this is merely a comet begins to weaken in light of the growing anomalies. It's essential to take this seriously due to both scientific authority and the challenge it presents. When an everyday observer highlights something peculiar, it may be seen as just an interesting news story. However, when a respected astrophysicist publishes a series of observations and quantifications of tiny probabilities, the conversation escalates to a more significant level. It transforms from mere curiosity into a genuine scientific inquiry. Vibe and his collaborators have documented numerous geometric coincidences, figures, and measurements that, when taken individually, might raise some eyebrows. But when viewed together, they begin to form a compelling case that is hard to overlook. The critical aspect is that several observed characteristics have very low probabilities of occurring by chance. If we are indeed dealing with a typical comet, the extreme collimation of a jet directed toward our star, its consistency before and after and the supposed apparent axis change all contributes to making a natural explanation seem unlikely. When this is assessed numerically, as Liu has done, the impact is immediate. The theory of a purely natural object weakens as more credible hypotheses emerge. The images and brightness maps provide concrete evidence. In images collected from various telescopes between December 14th and 16th, 2025, a sunward antitail is distinctly visible, projected towards our star. In the latest measurements, this antitail maintains its collimation over distances of approximately 500,000 kilometers, which is comparable to or even greater than the average distance from the Earth to the Moon. Brightness maps, processed with filters like Larsenina, unveil a linear, narrow and coherent structure that is significantly longer than it is wide. Moreover, wide-field images taken over consecutive nights display consistent orientations. The antitail holds an angle very close to the direction of the sun, and brightness profiles facilitate precise angular measurements, indicating a narrow opening of about 6 to 8. These specifics counter the notion of simple projection artifacts or camera issues. What we are observing is an extensive, relatively stable physical structure surrounding the nucleus. Additionally, the oscillating movement, or wobble, adds complexity to the narrative. More than just a lengthy tail, what became particularly intriguing was the periodic modulation noticed in the angle of the antitail during July and August 2025. Measurements suggest a wobble period of roughly 7.74 hours, plus or minus 0.35 hours. This implies that the launch point of the jet is slightly offset by a few degrees concerning the rotation axis. Essentially, the jet describes a conical shape, resembling the way a lighthouse beam traces a small circle as it spins. Why is this important? The geometric deduction becomes critical here. If the base of the jet is less than 8 off from the rotation pole and the axis, when projected into the sky, aligns nearly toward the sun, it appears that the jet is following the sun in an unusual manner. According to Liu, the chance of this fortunate alignment occurring randomly is about 0.5%. When factoring in the necessity for a similar jet at the opposite pole, post-perihelion, the combined probability plummets to around 25 millionths. In simpler terms, this indicates an extremely improbable coincidence: the persistence of the forward jet collimation and the peculiar golden blade. Both amateur and professional observers, including Dan Bartlett, Tony Scarito, and Tereus Theowang, have detailed a jet that seems directed forward, resembling a blade formation. Oddly, it also appears post-perihelion, still oriented toward the sun. Beyond its visual appearance, many reports describe a golden hue coupled with a narrow blade. Studies have indicated that the jet's collimation remains within 6 to 8 over distances of about 500,000 to 1 million kilometers. This is unexpected, as solar winds and radiation pressure should easily widen or deflect such an extended jet. Another astonishing coincidence arises from calculating the gravitational deflection at perihelion, which was about 16.4, equivalent to double the jet's opening. This opens up the geometric possibility that a jet cone aimed at one pole before perihelion has its counterpart mirrored at the opposite pole after perihelion. Liu emphasizes this as a noteworthy pattern, not just a chance occurrence. In straightforward terms, the configuration of the jet before and after perihelion appears to correspond with the angle of gravitational deflection. Now we reach the statement that sent chills down many spines. There exists evidence implying that the object's rotation axis seemed to shift direction after or, at the very least, The jet pattern and how the projected axis behaves in the sky suggests that something in the object's geometry altered in a manner that cannot be easily explained by straightforward thermal conduction or the simple sublimation of ice pockets. Observers have noted a change in trajectory, with some interpreting it as a maneuver, indicating active control over the propulsion vector. The physical aspect is vital here. If the jet's base was active before perihelion and subsequently turned inactive in that region, a natural desorption explanation would necessitate another ice pocket nearly symmetrically positioned at the opposite pole, both thermally insulated for months to avoid conduction. Liu categorizes this as an issue for natural explanations. The alternative would be the presence of thrusters or some kind of technological system intentionally ejecting mass in a preferred direction, such as Toward, the star of our solar system. This hypothesis could account for maneuvers, axis adjustments, and the persistence of collimation against solar wind. Amateur observations, including stacked images from home setups, variations in magnitude within minutes, and reports of jet wobble, contribute empirical evidence to this discourse. This goes beyond a mere theoretical paper. Actual phenomena have been seen and measured in the sky. Nonetheless, definitive proof will require spectroscopy, high-resolution imaging, and ongoing monitoring. Now, let us recap the 15 known anomalies concerning Atlas. Before offering an opinion, it's beneficial to meticulously list the anomalies that are pivotal to this discussion. Counts may vary, but here's a consolidated version derived from Liu's texts: a geometric and orbital retrograde trajectory that nearly aligns with the ecliptic plane, having a probability of around 0.2%. Timing and precise adjustments related to specific distances to Mars and Jupiter, indicating a planned approach. An extremely columnated sunward annotale that is unusual for comets. Rotation axis aligning with the sun's direction within approximately 8, with a probability of 0.05%, and a periodic jet wobble of 7.74 hours that can only be understood if the base is situated less than 8 from the pole. The jet's appearance before and after featuring unlikely geometric coincidences, demonstrates a composite probability of 25 millionths. The gravitational deflection at perihelion, calculated at 16.4, is twice that of the jet opening. An extraordinary geometric coincidence. The composition of the plume displays high nickel levels and low iron, reminiscent of industrial alloys with only about 4% water, which is significantly below that found in typical comets. The extreme negative polarization is unparalleled among known comets concerning physical properties. The nucleus is more massive than MUA, and other comparative comets, yet it is moving at a faster speed, which is peculiar for a common interstellar iceberg. The brightness and coloration exhibit a rapid clearing and are bluer than the sun near The alignment and collimation of the jet represent a newly identified anomaly as described by Liu. This indicates a requirement for extreme thermal insulation for active ice pockets located at the poles. Liu's numbers are impressive in their simplicity. The probability of the axis aligning with our solar system's star within 8 is about 0.5%, and the combined data before and after perihelion arrives at 25 millionths, a figure that elevates the likelihood of coincidence to an exceedingly rare event. Additional coincidences, such as alignment with the WOW signal and meticulously timed arrivals, further diminish the plausibility of purely natural explanations. The Loeb scale utilized for classifying interstellar objects as artificial or natural shows that Atlas garnered high scores, close to 7 or 8 prior to these recent analyses, where 8 would indicate strong evidence of artificiality without risk. The key point is that these ratings evolve as new data comes in, and Loeb signals continue to be updated as more observations are made available. What I can assert, without resorting to hysteria, yet without naivety, is that there currently exists a converging array of evidence, geometric, compositional, and dynamic behavior that renders the idea of a typical comet rather unsatisfactory. Science demands rigorous methodology. Bold assertions require unequivocal proof. Liu and his colleagues illustrate that the likelihood of coincidence is minimal. The next steps reside in the realms of spectroscopy, forthcoming imaging, and coordinated data efforts. If we confirm the presence of technological qualities, we could be confronting one of the most significant scientific milestones in modern history. Conversely, if this is not the case, we'll still glean tremendous insights into exotic cometary processes, which holds substantial value. In either eventuality, this case merits the utmost objective scrutiny and minimal bias. I invite you to comment and share your thoughts. What's your perspective on these coincidences and probabilities? Stay tuned for upcoming updates. January promises more data. Let's engage in thoughtful discussion in the comments with open minds and active curiosity.